Today our topic is development length. What is this? So to explain this, I drew on a cantilever beam. This is a cantilever beam. The column is here. I have some loads here. So the reinforcement will be placed on the top of the beam. The reason is my moment diagram uh, is like negative. So negative moments develops here. If positive moments develop, then we place the reinforcement at the bottom. So the placement of the reinforcement is not the question. Question is like something else. You can see the moment diagram. From the moment diagram, the maximum moment is at the face of the column or at the beginning of the beam. So my maximum moment is here at this place. Now, when I am placing the reinforcement, will I place my reinforcement from here, or I will extend my reinforcement some distance from the maximum moment to somewhere here? We need to extend that reinforcement. Why? Because the amount of force develops here, I need some length to anchor that reinforcement. That means whenever I am placing the reinforcement here, my concrete is anchoring it, holding it. Then, then I can apply force on my reinforcement. So I need some distance so that the anchoring force can develop inside my reinforcement to resist the tension. So to develop that anchoring force or the resisting force, I need to provide some length. That length is called development length. So I need to provide my reinforcement to some distance, that is called development length. So hopefully you understood the meaning of development length. At the same time, if I extend this explanation, say my maximum moment is here at the face. Say here I need 6 bars. I need 6 bar at the face where my moment is max. Now after some distance, my moment is decreasing. Say here I need only 5 bars. So as my moment is decreasing, the requirement of bar will decrease. Now at this point, say I need 5 bar. So will I cut 1 bar here? No. The reason is I need some distance to develop that resisting force or some anchoring force of my bar. So I will extend some distance, that is also called development length. Say it is somewhere here. So uh, although I do not need 6 bar here, but I cannot cut it. I need to extend some distance, that is called development uh, length. Okay, so uh, I will. So hopefully you understood how to do, what is development length. Now we are talking about development length for tension when there is some tensile force. If there is compression force, we have another equation, but main concept is here. Okay, so how to calculate development length? In your book, the equation is development length LD. L means length, D means develop. It is 3 divided by 40 Fy lambda A prime C psi T psi E psi S CB plus KTR diameter of the bar times diameter of the bar. Hopefully you can see here 3 over 40 Fy is the yield strength of the reinforcement, lambda is lightweight concrete factor. If my concrete is lightweight, A prime C is the unconfined compression strength of the concrete. Some discussion here, dB here and dB there. dB means the diameter of the bar. Uh, okay, so if my section is say this, so the diameter of this bar is dB, the bar that we are talking about. Okay, so some discussion here. What is psi t? Psi t is reinforcement location factor. reinforcement location factor. That means the location of this reinforcement. If I have uh, more than 12 inches of fresh concrete below the bar, then it is 1.3. Now, this I'm seeing it from your book. These factors might change with the revision of the specification. The current one I am using is saying that if I have 12 inches, say here, if I have more than 12 inches, that means slightly more than 12, or you can assume 12. It is not a like science, it's engineering based on your judgment. If you have more than 12 inches of concrete, fresh concrete, that means say your reinforcement is here, and this distance here to here is say 15 inches. Yeah, then this factor applies. Then that will be psi t will be 1.3 if you have more than 12 inches. So okay, so okay, right here that more than 12 inches. Your code says more than 12 inches. My logic says 12 inches or more. It's to be clear. Okay, then psi t will be 1.3. Otherwise, it is 1. Or otherwise, you do not need to consider. In this case, 2 inches, 3 inches, you do not need to consider psi t. So hopefully you understood what is psi t. It is reinforcement location factor. If you have more than 12 inches of fresh concrete below your bar. Okay, now I can discuss more like why do we need to consider that, but then my video will be longer. Simply, if the bar is like at the bottom, when you will place concrete, there will be so much force on this concrete, then the bonding will be good. In that case, it is standard. If it is here, my concrete is mostly here. When we will vibrate it, there will not be so much bonding here. So I need to provide more development length. Okay, this is why this factor is more than 1. Next, okay, if I write it, so psi t simply it is a reinforcement location factor. Then psi e, epoxy coating factor. So if I use epoxy in my bar to resist the corrosion, that is called, then we need to consider this epoxy coating factor. If there is no epoxy, then this factor is 1 or discard it. So this factor will be 1.5 or 1.2 or 1. 1 means no epoxy. No epoxy. If there is no epoxy, then it is 1. Now, when it is 1.5 or when it is 1.2, 1.5 will be if the, okay, if I go here, if this spacing is less than 3, that means if it is less than 3 times bar diameter, or this clear spacing is less than 6 times bar diameter. So if my clear spacing if my clear cover, if the cover is less than 3 times the bar diameter, or the clear spacing between bars is less than 6 times the bar diameter. Yes, I'm reading your book. It is in the same thing. That means epoxy coated bars or wires with cover less than 3 times bar diameter or clear spacing less than 6 times bar diameter. In that case, it is 1.5. If this is not the case, then 1.2. If no epoxy, on or discarded. Okay, so then the third one is size factor. Size is reinforcement size factor. What is that? If your bar is number 7 or higher, this factor is 1. So if your bar size is number 7 or higher, it is 1. If your bar size is number 6 or smaller, this factor is 0.5. 8. Why 0.8? Because if your bar size is less, there will be less force in this bar and it less distance. So this is why it is less. Now all these factors might change with the new specification. So do not memorize it blindly. It might change and do not memorize it. So whenever you design your beam or design your reinforced concrete, check your obviously you will check your specification at that time. So hopefully you understood this psi t, psi e, psi s. Now something to tell: the product of psi t and psi e cannot exceed 1.7. So the product of psi t and psi e cannot exceed 1.7. If I read your book, the product of psi t and psi e need not be taken as greater than 1.7. That means if it is more than 1.7, take 1.7. If it is less, no problem. Okay, so we discussed this portion. Now we have some discussion here. This one there's no discussion. This is the diameter of the bar. There's discussion in the CV. What is CV? CV is the like if I draw the bar, so say 3 reinforcement. CV is smaller of uh, cover from center and or half of CC distance. What is that? I wrote here very shortly so that I can accommodate here. Simply it is either this or half of this. So half of, that means whatever is smaller from center to the edge or center to the edge, whatever. So you will take 1, 2 and half of this distance, center to center of the bar. Whatever is smaller, that is your CV. If I read your book, it says use the smaller of either the distance from the center of the bar to the nearest concrete surface or 1/2 the center to center spacing of the bars uh, uh, being developed. That means this one. So you consider this or half of this, whatever is smaller, that is your CV. So it should not be a problem. Next one, KTR. What is KTR? KTR is called transverse reinforcement index or transverse reinforcement factor. So there will be some triber. Okay, let me erase this because I do not need it anymore. Now, so what is KTR? KTR. It can be calculated like 2 ways. Sometimes in your book, I see that they write this way. So 40 times A transverse divided by Sn. Sometimes I see that book writes this way. Okay, if I can remember. I do not need to see the book. ATR, FY, TR, 1500 Sn. Now both equations these are same. What is this? ATR, area of this. So if it is number 3 bar, so 0.11 inch square, 0.11 inch square, so 0.22 inch square. If it is number 3 bar. So okay, this portion is here, area. So area of transverse bar. Say if it is say number 3, that means 1 number 3, 2 number 3, it will be 0.22 inch square. Now what is FYTR? Yield strength of transverse reinforcement. The yield strength of this bar. Now commonly it is 60,000 psi. Okay, so that is yield strength of this bar. Again, this portion is about this. Now what is S? S means again it is the spacing of this bar. What is the spacing of this tie bar? What is n? Now n is something different. That means n is number of bar. That means these bar. Number of bar. How many bar? How many bar to be developed? What or how many bar we are considering for the development length? So n here is 3. So hopefully you understood this portion. Oh, now if you use this equation, you can see uh, if this is 60,000, if this is 60,000 divided by is 1500 is actually 40. Yes, 40. So you can use this equation or you can use this equation. Both equation will be equal if your y is 60,000. Typically fy is 60,000 psi. So you can use this equation or use this equation. Some more discussion here. What is that? This KTR, okay, it is done. So my discussion is done. Just to extend my discussion. What is that? Okay, maybe I can erase this. Now this is only for straight bar. If we use hook, that is a different equation. So number one discussion is KTR can be used 0 to be conservative. You saw that calculating KTR, it takes a lot of time, lot of works, not so many, but slightly. But you can assume KTR 0, but it will be a very conservative design. Now, something else. This whole portion, CB plus KTR divided by diameter of the bar cannot exceed 2.5. This entire thing cannot exceed 2.5. That is number 2. Another discussion is like if we provide more reinforcement, say we need 4 inch square, we are providing 5 inch square. In that case, we can decrease our length. So LD can be decreased by AS provided divided by AS required. I do not know whether you can see it due to the light, but say whatever you are providing divided by whatever you require by the equation. So say you need you need 4 inches square, you are providing 5 inches square to make it a round number or to select the bar. That means 5, oh, the opposite actually. So it is required, it is calculated or provided. Let me check your book again. Yes, so required here, required and provided. Say you need 4 inches square, you are providing 5. That means 4 divided by 5, that is 0.8. So you can decrease by, can be decreased 2 actually, can be decreased 2. That means say you need 4, you are providing 5, that means 0.8. So whatever your LD is, you can multiply by 0.8. Say if your L is 100 inch, you can provide 80 inch. That is the explanation. Okay, number 4, for hook bar, if you develop a length for hook, there is a defined equation which is very simple that will make your length smaller. Even development length for comprehension. I am not discussing these two here because it will be like longer. Okay, so something else also. So these two I am not discussing here. It's simple. You can see the book. What is the equation? Other one is if your bars are bundled. Say you are doing bundle. So for 3 bar, if your bundle is 3, increase LD by 20%. If your bundle is 4 bar, then increase by 33%. Increase by 33%. So whatever is this 1.33. So that is some other discussion. Okay, so I will stop here. In the next video I will solve some example, and also I will discuss the developer length for hook, developer length for compression. I will stop here. Thank you.